I am Dayan Gowde, Assistant Professor in Mathematics, Center for Distance Education, Shivaji University, Kolhapur. Today I will discuss the examples on root procedure, Routhian procedure, examples on Routhian procedure. Example: find the Lagrangian, Hamiltonian H, and Routhian R in the spherical polar coordinate for a particle moving in space under the action of conservative force. Solution: let a particle be moving in a space if x, y, z are the Cartesian coordinate and r, theta, phi are the spherical coordinate of the particle. Then we have the relation between them as x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, z is equal to r cos theta. Then the kinetic energy T is equal to 1 by 2 m x dot square plus y dot square plus z dot square of the particle in spherical polar coordinate becomes T is equal to 1 by 2 m r dot square plus r square theta dot square plus r square sin square theta phi dot square. Since the force is conservative, hence the potential energy of the particle is the functions of position only, that is V is equal to V of r theta phi. Hence the Lagrangian functions of the particle becomes L is equal to 1 by 2 m r dot square plus r square theta dot square plus r square sin square theta phi dot square minus V of r theta phi. We see that phi is cyclic in IL, hence the corresponding generalized momentum is conserved, that is P phi is equal to del by L by del by theta phi dot is equal to mr square sin square theta phi dot is equal to constant. Similarly, we find PR is equal to del by L by del by r dot is equal to mr dot. P theta is equal to del by L by del by theta dot is equal to mr square theta dot. Now the Hamiltonian function is defined as H is equal to Pj Qj dot minus L. H is equal to PR r dot plus P theta theta dot plus P phi phi dot minus 1 by 2 m r dot square plus r square sin theta dot square plus r square sin square theta phi dot square plus V. Eliminating the generalized velocity r dot phi dot theta dot between the equation 5, 6 and 7, we get H is equal to 1 by 2 m PR square plus 1 by r square p theta square plus 1 by r square theta sin square theta p phi square plus V. Now the Routhian R is defined by R is equal to P phi phi dot minus L. Then become, after eliminating r dot theta dot phi dot between 5, 6 and 9, we get r of r theta phi r dot theta dot t is equal to p phi square divided by 2 mr square sin square theta minus 1 by 2 m r dot square plus r square sin theta dot square plus V. Next example: a planet moves under the inverse square law of attractive force. Find Lagrangian, Hamiltonian, and the Routhian are for the planet. Solution: a motion of a planet is a motion in the plane. If r theta are the generalized coordinate of the planet, then its kinetic and potential energies are respectively given by T is equal to 1 by 2 m r dot square plus r square theta dot square, V is equal to minus k by r. Hence, the Lagrangian function is defined by L is equal to 1 by 2 m r dot square plus r square theta dot square plus k by r. We see that theta is cyclic in the cyclic coordinate in L. This implies that the corresponding generalized momentum, angular momentum of the planet is constant on the p theta is equal to d by L by d by theta dot is equal to mr square, theta dot is equal to constant, theta dot is equal to p theta divided by mr square. Pr is equal to d by L by d by r dot is equal to mr dot, therefore r dot is equal to Pr divided by m. Now the Hamiltonian function is defined as H is equal to Pj Qj dot minus L. H is equal to Pr r dot plus P theta theta dot minus 1 by 2 m r dot square plus r square theta dot square minus k by r. On using equation 2 and 3, we obtain H is equal to 1 by 2 m Pr square plus P theta square divided by r square minus k by r. This is the required Hamiltonian. Now the Routhian is defined as r of r theta p theta r dot t is equal to p theta theta dot minus l. R of r theta p theta r dot t is equal to p theta theta dot minus 1 by 2 m r dot square plus r square theta dot square minus k by r. Eliminating theta dot, we get r of r theta p theta r dot t is equal to p theta square divided by 2 m r square minus 1 by 2 m r dot square minus k by r. This can also be written as r of r theta p theta r dot t is equal to p theta square divided by 2 m r square minus Pr square divided by 2m minus k by r, and this is problems.